session schedule. Good morning, one and all. Today
of
we are
ISIC
at the
convention
last
theme
session,
session
that is technical session
of
schedule.
engineering innovation for next gen digital agriculture of
We are
ISIC
sitting in the
convention
auditorium
theme
hall of
session
College of Agriculture Engineering.
of
Now,
engineering
I
innovation
request
for
our
next
honorable
gen digital
respected
agriculture Vice Chancellor
we
Dr.
are sitting in
Indramani
the
sir to honor
auditorium
the
hall
chair
of College of
as the
Agriculture
chairperson
Engineering.
of this session.
Now, I request our
I
honorable
also request
respected
Vice Chancellor Dr. Indramani sir to honor the chair
Dr.
as
Dharmendra
the
Saraswat sir, Professor, Food University, USA.
I also
Request to please come on the stage. Dr. Dharmendra Saraswat sir, Professor, Food University, USA, to join on. To please come on the stage. Online. Okay. Request sir to join on to honor the chair this session and chair online for this session. I also request Dr. Bhuvanand sir, the chair and general chair for this session. I also request Dr. Bhuvanand sir, Department of Agriculture, National Chair as the podium for this session. To welcome our I request Dr. Abhinandan sir, Department of Agriculture, Extension, by own Parveen, and to welcome our Honorable Vice Chancellor sir, Dr. Indramani sir, Vice Chancellor, Basangaram National Productivity and Parveen, by offering bouquet and moment. I also request Dr. Kadam sir to welcome our respected honorable guest, Dr. I also request Dr. Kadam sir to welcome our respected honorable Dr. Kadam sir to welcome our Bhuvanand sir and Dhamma sir by offering bouquet and memento as a now again I request Dr. Kadam sir to welcome our Bhuvanand sir and Dhamma sir by offering bouquet and memento as a memento for this session.
Hello.
Now I request our Honorable Vice Chancellor Sir Dr. Indramani sir to deliver his valuable speech as a now I request our Honorable Vice Chancellor Sir Dr. Indramani sir to deliver his valuable speech
दो
as
स्पीकर्स हैं
हाँ
और दोनों ऑनलाइन है
ओके सर
एक की रिकॉर्डेड स्पीच है सो आई विल रिक्वेस्ट ऑर्गेनाइजर्स to first play Dr. Dharmendra Saraswat's list. Before that, I welcome, I do little formality. Now you allow me to start?
yes sir that only I am asking for the
allow for मेरे को start करने के लिए.
yes
Invite
now
now.
I request our Honorable Vice Chancellor sir to start this session as the chairperson of this session.
Thank you. Friends, we are honored that we have in this hall Dr. S.N. Jha Sahab, who is the Deputy Director General Agricultural Engineering and President of ISAE. And we have Nawab Ali Sahab, who is has been former Deputy Director General Engineering and a very renowned processing scientist. Then we have colleagues from our looking for Srivastava Sahab. I think he is outside, he will be coming. P.K. Srivastava Sahab, scientist from different institute and universities. Dr. Jha Sahab, may I request you to join here, please? आ जाइए हाँ So friends and Gopal Shinde, Dr. Gopal Shinde and Dr. K.K. Thakore, so very hardworking scientists are with me here. And then all the delegates, and I'm expecting that more people will join here. And friends, you will agree that first day we had symposium, theme, and symposium theme was on education. And the convention theme is on engineering innovation for next gen digital agriculture. We have been talking from last 2 days, next gen engineering only, next gen digital agriculture. But this is more focused and we were expecting actually more speakers, but because of their other engagements, they could not come physically. That the job was expected from ICRISAT, he promised, but he could not come. But nevertheless, we have two very important speakers. Dr. Bortiwan was here. He delivered talk yesterday, but there was some urgency, and he requested that if you people permit, I can join online, and that's how we said okay. So with this kindly, to start with, we can request my team that play this Dr. Dharmesh Saraswat presentation. It is on innovative student-centric methods to prepare next-gen engineering innovations. And Dharmesh Saraswat is a professor at Purdue University, USA, and before that he was our colleague. He did his master's from IRI. We were together at IRI, and then he joined Chandrasekhar Azad University as an assistant professor, then moved to IRS and joined CI Gopal, and he was a scientist there, and from there he moved to University of Arkansas first and for his higher education, and he completed his PhD, and then initially, he joined first University of Arkansas and now shifted to Purdue University. Of late, he has been promoted to as a professor. Most of you know he has come here twice in this university also, and he keeps on, he remains in touch with all institutions of agricultural engineering. He is a very good friend of Dr. Sindha, and so now let us listen Dr. Dharmesh Saraswat, his thought on innovative student-centric methods to prepare next gen for engineering innovation. Please.
Good afternoon, everybody. The honorable chairpersons of the session, the rapporteurs, other presenters, the Honorable Vice Chancellor and the organizing committee who have given me an opportunity to reach out to you through this virtual medium, delegates from India and abroad. I welcome you all to my presentation on innovative student-centric methods to prepare next gen for engineering innovations. Today, we will explore innovative teaching methods and cutting-edge technologies that are shaping the future of farming. I trust you all agree that digital agriculture is revolutionizing farming by integrating advanced technologies to address critical challenges such as rising production cost, climate change impacts, and labor shortages. That's why my focus today is on how we can effectively teach these concepts to engineering students using innovative methods. The transparency in learning and teaching, or in other words, TILT framework, is crucial for effective education in digital agriculture. It emphasizes clear communication of assignment purposes, detailed task instructions, and explicit evaluation criteria. This approach significantly improves student performance, promotes equity, and enhances motivation in learning complex agricultural engineering concepts. Another innovative teaching method is the course-based undergraduate research experience or CURE program. CURE integrates original research into coursework. It's particularly effective in digital agriculture education as it involves students in making novel discoveries, producing broadly relevant outcomes using scientific practices, collaborating, and iterating on their work. This hands-on approach prepares students for real-world agricultural challenges. When it comes to novel technologies that are impacting agriculture, I assume that you all agree that digital twins and artificial intelligence are transforming agriculture. These virtual replicas of physical farming systems, coupled with generative AI, enable predictive analytics for crop yield optimization, resource management, and risk mitigation. Students can gain practical experience by working with these advanced tools in simulated environment. Robotics and automation in agriculture, such as autonomous tractors, robotic weeders, etc., are not only addressing labor shortages but improving efficiency as well. At the same time, the use of drones or unmanned aerial vehicles along with the edge devices is also leading to some practical applications such as real-time plant count and weed density mapping. So while challenges like cost and integration exist, exposing students to these technologies prepare them for the future of farming. Big data and machine learning are pivotal in modern agriculture. These technologies enable predictive modeling for pest management, weather forecasting, and market trend analysis, etc. Engaging students with real farm data projects provides invaluable experience in agricultural data science. Sustainable farming practices such as vertical farming, precision irrigation, and renewable energy integration are crucial for the future of agriculture. Student-led sustainability projects in these areas not only teach important concepts but also contribute to solving real-world problems. Looking ahead, blockchain, gene editing, and augmented reality are set to further transform agriculture. By encouraging innovation through collaborative research, we prepare students to lead in these emerging areas, ensuring they are ready to tackle future agricultural challenges. As I conclude, remember that integrating these innovative teaching methods with cutting-edge agricultural technologies will prepare the next generation of engineers to revolutionize farming and address global food security challenges. So thank you for your attention. Before I end, I would like to bring to your attention Agriculture Informatics course catalog that we have developed utilizing funding from National Institute for Food and Agriculture. 2 webinars have also been developed on these course curriculum. So if you are interested to take a look, please go to this website, and if you are unable to find the web links for the webinar, please send me an email and I will definitely share that with you. So with this, once again, thanks Honorable Vice Chancellor Professor Mani for giving me this opportunity, and I wish ISA convention a grand success. Thank you and Jai Hind. Good afternoon everybody.
Thank you, Dr. Saraswat. Very brief, but basically a base for the next gen digital agriculture, like industry 1.0 to 4.0, similarly agriculture 1.0 to 4.0, and student-centric approach. And I think the message is that on next gen agriculture, we have to prepare, from the beginning. You will be happy to know that yesterday Dr. Sanjha and myself spent whole day in main hall, that means the convocation hall where inauguration was done. And and intensively Dr. Sai interacted with the school students to enthuse them that future agriculture is engineering agriculture, and for engineering agriculture the best talent is required, and that's why we have a very Pradhan Sevri school, Navodaya Vidyalaya, in our campus, and then Shivaji College with another student came, and we saw a lot of enthusiasm among the students. So, strategy of agriculture engineering fraternity, led by ISAE, is to basically encourage school students, to take up career in agricultural engineering. And very, very interactive session was held. That should be the approach, that from beginning, then we had discussion with BTech student from agricultural engineering and food technology. That also was very, very, intense discussion. And in fact, one of our friends came from Purdue University, Kinsley, who has been again a good friend, and he was a scientist at Sheffield, Louisiana, from where he shifted to US, and a very wonderful faculty. He has been doing, excellent. Then I visited his lab, and there actually in US, he showed me that Flexi lab. Flexi lab means they create lab, if some problem is there, they will create that lab, find out the solution, stop it, same place they will put another lab based on problem. So Flexi lab concept, 4 years back, 5 years back, when I visited Purdue University. So he showed me, and ISA honored him with fellowship, thanks to the President and the Executive Council. So he also interacted, late evening. He had less time, but at NAHEP, all PG, PhD students gathered there, and I was told by Dr. Gopal around 70. PG, PhD students
Recording in progress.
gathered there, and they interacted. So what we are beginning in the afternoon, there was a very, very important session with the farmers. So what ISA and BNKB has been targeting that all stakeholders, present or future, they all should be basically benefited, engaged, integrated, and taken together to prove the might of engineers in agriculture. And we have been In fact, very, very successful. Last 3 days in all the sessions, wonderful discussion, wonderful, very fruitful, interaction has been there. So, in this series, we had, now, we had talk from Dr. Dharmendra Saraswat, so what is happening abroad. And now the word is, we know that Vasudhaiva Kutumbakam, so in science also we have to feel that Vasudhaiva Kutumbakam, we can't remain behind any country. So that's why these international symposia, others are very, very important and very successfully we have implemented. And now I invite Dr. Sunil D. Gorantiwar, and our friend yesterday he was here in mechanization and automation session. He gave a talk, and today he is going to speak on revolutionizing agriculture, digital innovation for sustainable future. So one speech was revolutionizing agriculture, digital innovation being done their future. Another that so one our conditions how we can customize them and make them the best use and think about better solution. So now I invite Dr. S.D. Sunil D. Gorantiwar. He is a very able agricultural engineer and soil and water conservation and irrigation. Sunil D. Gorantiwar. He is a very able agricultural engineer. Director of Research and at soil and water conservation and irrigation. Rahuri expertise. Recently he has, but his contribution has been immense, basically. I remember one, and I congratulate that. But his contribution has been immense. Secretary Agriculture was. I remember one Delhi, and we were having a meeting. Probably I was making a presentation, and during the presentation, Secretary Agriculture said that this digital center, the one which he developed at Rahuri, Secretary said we need more Rahuri-like centers, we need more Rahuri, and credit goes to Dr. Gorantiwar and his team. Congratulations. Dr. Gorantiwar.
Yes, thank you very much.
Okay. So, and we are expecting a lot of guidance from you to young engineers in time to come. Now I invite you for the, your talk.
Yes, thank you very much. Yeah. Very good morning. I hope I am audible and my slide is visible.
Before he starts, I convey greetings to you all. Today is Bal Divas, so congratulations.
Am I audible, sir?
Yeah.
And my slide is visible, no?
Yeah.
Okay, thank you very much. Very good morning to all. Honorable Chairman of this session and Honorable Vice Chancellor of VNMKV Parbhani, Dr. Indramani sir. First of all, thank you very much for the nice words and praises for our team. Thanks for that. But all of us know that you are a guiding force for digital and precision agriculture technology, not only to us, but I think for the entire country. So we get a lot of insight from you, and thanks for that. Thanks to all other experts. My topic is revolutionizing agriculture with the help of digital innovations, but this is for the sustainable future actually. So maybe a few minutes I will spend in this sustainability for the agriculture, and then maybe on the digital innovations. My talk will be mainly focused on the innovations for the Indian situation, that is wherein there are small farms and everything is varied. And mostly I will be talking in perspective of the future direction rather than what we did, because yesterday I got opportunity to deliver a lecture on drone robotics and AI in farm machinery session, and one of my colleagues today delivered a lecture in soil water engineering session on digital agricultural technologies for irrigation. We talk a lot about the sustainability, but for my young friend, when we say the sustainability or sustainable development, this means that whatever we do today, our needs should also be satisfied, but without compromising the ability of the future generation to satisfy their needs. So this is very important. This not only we only produce for ourselves, but we shouldn't compromise or reduce the ability of the future generation to meet their own demands. That is the sustainability, and this returns should be increased, but at the same time, resource input use efficiency should be improved, and along with that, there should be emission reduction. We should conserve the natural resources. We should reduce the pollution. We should protect biodiversity and ecosystem, and we should also enhance the resilience of ourselves. But we shouldn't also forget the gender and social inclusion. We need to promote the equity, and also, of course, health and well-being are important. So all these are the sustainability objectives, and those have already been outlined appropriately in Sustainable Development Goals. So there are 17 Sustainable Development Goals, and out of these, 9 addressed to agriculture, and so agriculture is really important. And when we say that we have to find the sustainable solutions for the agriculture, then the role of engineering is very important. Okay. So when engineers generally find out the engineering solutions, and these solutions currently mainly focused on technical and technological approaches, and those are directed towards improving functionality and efficiency. So that is, we mostly focuses on the productivity actually and efficiency and so on. But when we say that the sustainable engineering solutions, then we need to think beyond the functionality and efficiency and productivity. We need to consider the environmental impacts. So we need to minimize the environmental impacts, and also we need to have the long-term sustainability. So as an engineer, I must think about the functionality and efficiency, but at the same time, I shouldn't forget the environmental impact and long-term social sustainability as well. And let us not forget, we are agricultural engineer. We have the domain of both agriculture and engineer. So combined together, we can do a lot of things for developing the sustainable agricultural practices. But we shouldn't also forget that we cannot do this in isolation. Yesterday, our chairman sir has given, I think, 15 minutes guidance to farm machinery group, and he clearly mentioned that we must collaborate with the industry. So this is very important. We must collaborate with the other branches of engineering. So in pursuit of finding the sustainable solutions for agriculture and also the development of the technology, we need to be driver, but we could not do in isolations. Potential of these sustainable engineering solutions, say when we find the sustainable engineering solution, the environmental impact we need to consider, we need to minimize that, we need to conserve all the natural resources, maybe soil, water, air, social equity we need to consider, and it should be in long-term perspective. And some of the examples of sustainable engineering solutions are, say, for example, renewable energy system. I think our chairman sir might have given the address on agrivoltaic, energy efficient buildings, waste production and recycling, sustainable material and manufacturing process. So these are just examples, but precision agriculture is one of the important sustainable engineering solutions as far as the entire sustainable development is considered. So these are certain examples of sustainable solutions, but our mainly target is the agriculture. So precision agriculture is one of the technology wherein we can find the sustainable solutions for the agriculture, and digital technologies have tremendous role in precision agriculture. When we say that the precision agriculture means everything we need to do with the precision. I have shown here 2 photographs. So one photograph is in the polyhouse and another photograph, say maybe in the open field condition. We know that entire agricultural system is very variable. So variability in weather, variability in soil, variability in crop, variability in management system. It is complex actually. No other system exists in this world heterogeneous or complex than the agriculture. If we want to find out the sustainable solution with precision agriculture technique, we need to consider this variability. So what we do in open field condition, we try to respond to the variability actually. So we respond to the variability to mimic the uniform environment. But in say polyhouse or protected cultivation, what we do, we remove or minimize the variability by creating the near uniform environment. If you say in polyhouse, we create the environment which is quite uniform and which suits to the crop growth actually. But say polyhouse technologies, they have limitations actually. We cannot adopt this technology all over our agricultural land. Most of our agricultural land is in open situation, and that is quite variable, and we have to respond to this variability to mimic uniform environment. And for that, all these digital tools are what we call can be used. Here I have shown the variability in soil, weather, crop, and also management practices. Soil differ from place to place. Weather has temporal spatial variability. Crops have spatial temporal variability, and management practices vary from farm to farm. Whether we can address this variability with the traditional approach, of course not. It is not possible to address this with the help of traditional approach, even if we are equipped with the instrumentation. Okay.
What happened? Call him. हो गया इसमें एक्टिविटी क्या है?
Recording in progress.
Here, artificial intelligence and machine learning, robotics, precision machinery, sensors, IoT, mobile and
Recording in progress.
drones, geoinformatics that includes artificial intelligence and machine learning, robotics, precision machinery, sensors, IoT, mobile and web technologies in isolation. Drones, we can use this technology together as well to develop the tools and devices for the small farms. There are several benefits of using digital technology. First thing that we can apply anything with precision. Targeted application is possible. So just water, whenever we want to apply water and in whatever quantity we have to apply water and chemicals, that we can decide with the help of digital technology. We can optimize the resource allocation. So that is, we can relate application of the resources to the yield or to the net returns. Then we can increase efficiency. So whenever there are repetitive and labor-intensive tasks, then digital technologies can address this issue. At the same time, we can enhance crop yield, quality, and production. Reduce labor cost. We know that the labor is a tremendous problem nowadays. While we are discussing in one of the cotton conference, we came to know that the cost of picking the cotton with the help of the laborers may be equivalent to the cost of cotton itself, maybe in another 5 years' time. Okay, maybe the farmers may abandon cotton picking actually, or cotton cultivation. But digital technologies can offer solution to this. I think Parbhani University is also working on this cotton picking. Then safety and ergonomics issues, they are also addressed. Say, for example, if we use drone for chemical spraying, then we protect the health of the human resources. Otherwise, we know that whatever happened in Yatmal district of Maharashtra just before COVID, because of the chemical spraying, 2 farm laborers had to lose their life. In sustainability, environment is very important. With the help of the precision application of the inputs, we can minimize the chemical uses. At the same time, we can minimize waste, we can minimize pollution, and more importantly, we can promote regenerative practice with the help of this precision agriculture. Another thing is that in precision agriculture, we use digital tools, and we can have data-driven decision making. Say, for example, if I want to make the decision regarding the time of spraying, then I can, digital technologies enable us to gather all the data in real time, analyze, and then advise the farmers whether this is the right time to spray or not, whether this is the right time to apply input or not. So data-driven decision-making is very important, because that is considered accurate and precise. And then in blockchain management, it enables us to improve food safety, because we can automate the tracking and monitoring, and at the same time, these technologies enable us to reduce the contamination risk. But at the same time, there are so many challenges as well. And as an engineer, and especially agricultural engineer, we need to address these challenges. And in pursuit of addressing these challenges, we also get certain researchable area for us. First challenge is technical. Navigation and localization in dynamic environment. This is the challenge because all these digital technologies depend on the network connectivity. And
that's
that
is
a still a problem. Yes. Yes.
5 more minutes.
Yes.
Kindly,
thank you.
kindly.
This
There are actually
there,
two,
cost and affordability. Safety.
No, I just tell there are 2 more speakers. We have President from Nepali Society of Agriculture,
fine,
Agriculture
fine.
Engineers.
I will complete in
So
5
we want to
minutes.
include, listen his
So-
experience quickly.
Yeah,
And Dr. Gopal, so
Yeah.
7 minutes we want to give before we switch over to our concluding session.
Yeah. Please give me
Please.
5 minutes, or
Thank you.
I will complete. Or I can end here as well. Go on.
Thank you very much.
Yeah. How many minutes? Okay. Then these IoT-enabled technologies, they are related. Sorry, digital technology, they are related to IoT. Then the sensors. Then at the same autonomous mobile applications, I will just go up for irrigation management. This is the application for fertigation management. We have seen yesterday drones we can use for spraying. Drones we can use to prepare the prescription map that what I have shown here. How we can use this? There is a protocol as just like spraying protocol is there, mapping protocol is also there. So we can use that mapping. In robotics operation, yesterday I got opportunity to present few of the things. In case of robotics operation, there are many other things, many other tasks that we have to fulfill right from
Try to connect him again.
Recording in progress.
to 1,817 crores, and there are three fundamental things in this case. One is creating the database in the National Agriculture Mission in India. All the form will be mapped with the attributes of the soil, environment, land records, and everything. So once this is done, the task of the researcher will be easy because each and every form is mapped, and each and every form will also be map for the soil type as well, and this is superimposed with the decision support system. So all kinds of the AI driven decision support systems are expected to take in this digital agricultural mission of India. We also call this as the AgriStack mission, and the particular point of focusing in this was that agricultural engineer we have a role in all the three aspects of this digital agricultural mission, and of course we are working in this direction. So if we do this in next future, our farmer will be the smart farmer. This could be the reality. Really means maybe farmers, they are using the cameras and drones and tractor together, and the harvesting machine like this, and finally just way forward, whether digital agriculture technology is reality, yes. Job losses, of course, no. We'll be creating the what we call as the more convenient jobs rather than our people working in the very difficult field situation. Opportunities are of course used. Sustainable, yes, addressed in the beginning because it enables us the precision application. Make us lazy. This depends actually. Maybe if we are too much dependent on the digital technology, it may make us lazy. But if, of course, depends on DAT scientific tools, depends on how we use actually. So just like mobile, if we use this for positive purpose, we get positive results. Equitable, yes, because we can address the needs of the small farmers, each and every element of the society, but we need to adapt to this digital agricultural technology positively. Then only we can reap the harvest of this digital technology. And finally, this will surely enable us to reverse the migration. Currently, we know that there is migration from rural to urban area, but if we equip the farmers with all these kinds of the attractive technology, that will enable to address all the issues of productivity and sustainability, surely there will be reverse migration. I think those days are not too far. Thank you very much, and thank you very much for giving me opportunity for sharing some of my thoughts on the future perspective of this digital agriculture technology. Thanks a lot.
Thank you, Dr. Gorantiwar. And my dear friends, the last slide is the important slide. What has happened till, from last, last, our century, that migration has been from villages to city. What digital technology will ensure reverse migration from city to village? And that has already started, let me tell you, in some area, already started. Many people in Maharashtra has find that, they have shifted from Mumbai and working in Marathwada area. One great example is global, this Parli, the place where Mr. Mayank Gandhi. The whole group they shifted to Marathwada and Parli, and a big system where they are helping the farmers. Similarly, many people from, who are employed of IT and city life and all, they will return back to village, do farming, advanced farming, and not only that, they will help the rest of the farmers. That is what is expected from digital agriculture. Let me tell you that automation and mechanization, which we have behind it, including irrigation and value addition and processing, that is going to raise the standard of agriculture. When there was a time when, plowing was done by desi plow and, walking behind desi plow and some 23 kilometers per acre and all drudgery and all, so agriculture is treated as not a very good job. It is full of drudgery. But if you give same farmer or farmer's son and daughter, give a tractor, and he is sitting on a tractor holding the steering with open arm and with honor and prestige. That is going to give prestige not only to farmers, but farming also. And that's why we are talking this reverse migration will happen. Mechanization has changed social engineering. I tell you one example of my own example. When I was a small kid, a small boy, I was just in a village working and seeing even farming activity also. And many times I was, मुझे कहा जाता था कि जाइए और ये बोलाइए यहाँ आप इस खेत पर काम करने के लिए जो आप लेबर कॉलोनी को करते थे कि आप आओ और इस खेत पे काम करने, वहाँ हल चलेगा, यहाँ हल चलेगा. अभी रिवर्स हो गया है. my brother is having a tractor which he custom hire also. Same person जो 1 एकड़ जिसको मैं बुलाने जाता था कि आप आकर के मेरे खेत पर आज ये चलेगा ये चलेगा, वही आदमी कहता आज आइएगा मेरा खेत जोत दीजिएगा आज अपने आदमी को भेज करके। ये जो चेंज है सोशल इंजीनियरिंग जो मैं बात कर रहा हूँ वो जो है बहुत महत्वपूर्ण है, ये बात समझने की जरूरत है। और वो इस ऑटोमेशन एंड मैकेनाइजेशन ने एक लेवल तक ले आया है, डिजिटल एग्रीकल्चर नेक्स्ट लेवल तक ले जाएगी। और मैं डॉक्टर गोरंटीवार को बहुत बहुत धन्यवाद देता हूँ, बधाई देता हूँ कि उन्होंने इस बात को जो है समझा और इस बात को उन्होंने हमारे सामने रखा है और आपके सामने कि कैसे डिजिटल एग्रीकल्चर रिवर्स माइग्रेशन आएगा। अगर आपका सपना डॉक्टर गोरंटीवार सच होता है तो फिर ये समझिए कि रियल जो है ना एग्रीकल्चर पूरी की पूरी बदली हुई दिखेगी। Friends, we welcome our friends, Shri V. Prasad ji. He is a very able agricultural engineer, internationally known agricultural engineer from Nepal. He is currently President of Nepalese Society of Agricultural Engineers. You remember that we organized ISI annual convention at Pune, and Dr. Gorantiwar was there to Rauri, and the venue was Pune, and Dr. Gorantiwar was one of the chief organizers. And at that time, a big team from Nepal had come, and we signed ISI signed an MOU, that means with the Nepalese Society of Agriculture. A big team had come. We were expecting 4-5 people this time also, but many of them are busy. Dr. V. Prasad was supposed to reach here on 14th only. He was in Thailand and teaching at AIT Bangkok at the different centers. But he made it that he is now here with us, and we will have a brief presentation from his side also. So welcome, Dr. Gopal Sindhe, and that is on digital agriculture at Parbhani. And just to inform you that at Parbhani, at least in drone area, we have started Dr. Jha 3 activities, and as I mentioned, we are doing with the industry. And one is that RPTO. Another is 6-month course, and with all our trainees are here. Please stand up, all of you. So they are the one. We have industry with us, 6-month training course, university and industry joined hand, signed MOU, and started this training program on drone. And similarly, with another industry, we signed MOU. I don't know, somebody is here from not Daksha is later on. No, that our program of custom hiring. Yeah. So we started custom hiring program, with the industry and farmers field, and wonderful successful program. And then many other, because we have different centers we have started. So message is, as Dr. Gorantiwar said, if you want a successful activity in new areas, join hand with industry, or allow industry to join your hand. Thank you. Dr. Gopal is, just in 7 minutes, just walk through.
Yeah, will you start my presentation?
Dr. Gorantiwar is faculty and head of Department of Pharmacy and Power, and he was NAHEP PI.
Thank you. Respected Chairman of this today's session, Honorable Dr. Indramani Sir, Vice Chancellor of this university, who is a backup for the entire energy spectrum as you have seen and enjoyed in the NAHEP Center and University campus. Today, respected Saraswat Sir is online. Respected Gorantiwar Sir is also online. Respected guest who is arrived from foreign countries, and respected all of my senior professors, Professor Nadre, Professor
Please,
yeah.
time
So
is
I'm
7
just going
minutes.
to start, my time is started now.
Wow.
So I'm going to present on mechatronics, agri-bots, agri-drones, agri-AGVs, IoT tools, artificial intelligence, CAD and CA precision agriculture. These are all new terms which were introduced in 2018. It has been accepted universally with all conception by world scenario. Now they are integrated to the curriculum. Next. The entire center which we have presented here, I'm really humbled to invite all respected senior dignitaries to please visit NAHEP Center. And at this NAHEP Center, we have established agri-board, agri-drone, agri-AGV, and 5 other portfolio which are very much attractive. Like CDKS is a climate-based decision knowledge support system. Then we have a seedling nursery processing automation system, food processing automation, then smart portable machinery and instrumentation cell. So looking at this present all scenario, it's like to begin with the foundation, and that foundation has been created with the inspiration of Indian Council of Agriculture Research and World Bank project. So I really thanks to Honorable Vice Chancellor for being with us day night to participate. Next. These are the advanced technologies that we hold, and the projects that students are doing. I'm just showing them, because if you come to visit this center and really see online how this practically the student has done, that will be credential to make the students researcher up to the copyright and patent. Next. We have a solar design and equipment system related all facilities. We have a hydraulic pneumatics, sensors lab, and different types of artificial intelligence models with deep machine learning models also we have created. Next. Students are getting knowledge to make the practical deterministic approach by designing different types of experiments for the real practical work which is helping to the actual farm level achievement. Next. The small portable machineries the students are designing in the CAD/CAM software, they are preparing. In fact, this is one of the inspiration which has begun in 2007. Then this CAD/CAM has extended to the great extent that the students are designing, developing, and then testing it on field. Next. There are some good achievements in developing small portable machineries which are custom and economically affordable. Next. The now as a present transplantation, vegetable transplanter we have designed and developed with the help of the CAD/CAM software. We designed all the components. Now it's practically we have come out with the results that the different kinds of grafted plants which on the grafting robots we can transplant them to this by using this robots. Next. There are different, next. This is what, Professor Gorantiwar has mentioned. We are also interested to make the cotton picker, and for which the main object is to design the suction pump, which is hard. So we have made a system in CAD/CAM model to get the CFD analysis, structure analysis, and accordingly the sucking pressure for the cotton can be obtained by using this technology, and then finally we go to the fabrication after getting confirmation of technical specifications. So we have made now electric vehicle to pick up the cotton. Next. The state of art, it was earlier in the beginning stage, which was just manually being operated. Now we made it electric vehicle, and also the robotic arm, which is to be pick up by using the grippers. Next. The kind of operations that you can see, there are some difficulties like petals or maybe dust or some kind of obstacles are coming while collection of the cotton, and that has to be filtered at the time of sucking pressure. So we made one fine mesh to also trap the seeds so that the ginning process can be happen at the same time. Next. The food processing automation in 3D food printers we have designed and developed by use of the IoT tool. Students, or maybe it can be a really boost up to the female organization, those who are nowadays Bachat Gat they are doing. They are every day, they are thinking of some new object. We are designing the new master templates, and then the women farmer, they are working at their home by using the mobile. They can have plenty number of designs of the extruded, fine extruded this 3D food printer. Next. The grain cleaning, grading, and then packing operation. We made this with the help of Russian scientists. Their team came from Russia. They have just given the pump, suction pump, the pneumatic system, and then we have entirely designed and developed this machine. So they came to us and saw that how it can be work on the Indian battleground. They really appreciated. They also invited me in Russia to see their all kinds of activity. Now there are 3-4 countries, Russia, Belarus, then we have Japan, then we have different Asia Pacific countries. They are connected to make us collaboration not only on the paper, but our Honorable Vice Chancellor has inspired us to start working. So we are sending the students. So last year we sent the 55 students to 9 countries, 25 faculties to also 9 countries, and they did their work for more than 1 month, and the real rewards appreciation has came out through the Nature Springer publications, which was invited in Belarus on 5th June, last 5th June. So I really appreciate the all kinds of activities. Next. The robots, which are really inspired. We can have a grafting of brinjal and tomato plant. The rootstock of brinjal, wild brinjal, and the tomato, which is cyan, we are developing the different kinds of genetic variety. Now new suggestion came, sir. Ayush Mantralaya has invited, as I was suggested, we do Panchakarma, so for that we need Shatavari, Ashwagandha, and so many kinds of. So those medicines and their similar genetic characteristic plants can be grafted together. We have a healing chamber arrangement, and that after grafting, the plant which comes is already been like a Panchakarma. So instead of crushing more than 2 plants, we can have a crushing of only 1 plant. So that has boosted to Ayurveda industry and their exports. So, yeah, next. Thanks. So these are the specifications and comparison. Next. These are the achievements which we have just compared and saw that how this grafting can be succeeded. Next. The students are doing experiments after grafting. These fruits are, you are observing, and they are found like the characteristic of a brinjal as a hard shell cover, and then seeds with the different genetic properties. So next.
2 minutes में slide खत्म करो.
Next. 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 So these are the grafting process, and now this is another last, just one important that the robotic system in the field, we are able to now recognize pink ball armworm characterization. So we made a deep machine learning and their characterization to identify at the very earliest beginning stage so that we can take immediate action. We have a plant population, fruit population counters, which are designed to know that farmers will know how many plants are there in his field, how many fruits are there in his field, how many of them are infected, how many of them are good or bad. If there is an infection on some particular plant, so it will be like a 1002 number plants, and on that which 4370 number of fruit, there it is insect. So GPS GIS will locate and say you spray at that position only, so that pesticide can be saved. Next. Some of the practices: herbicide, organic pesticides, fertilizers. These are nowadays biomix, the products, kinds of products we are also using. Next. Next. We have a drone lab. Next. So next. So this is related to IoT tool, now really inspired, as Honorable Vice Chancellor told, you go to the student and ask them to involve. So this is the only one first example I will like to focus. The animal is get assessed and their medical history is get prepared by just tagging RFID. Next. Any time when patient is admitted, doctor can operate from a remote place. Next. Next. We can have a digital plants now as a model. हमने ये बनाया है. Digital plants द्वारा characterization करके उसके genetic properties हम insert करके हम analysis करके हम उसका study model बना सकते हैं. Next. 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 I will share this entire presentation to everyone. Thank you, sir. Thank you.
Friends, thank you very much. We wanted to, show that what BNKB Parvani has been doing from last, there is a program from last 2-3 years. The center is very near, and I request all of you to please visit. The unique thing is that this robotics section is very, very important, and drone section, we have, at the commercial level, and many other things. And what he said, that 85, our faculty and student could join the advanced lab of 12 countries, and got trained, and they are really contributing a lot. And we have received a big funding from BST as a center of excellence in digital and sustainable agriculture. That was challenged that 17, 18, 19 crore.
Yeah, 18.7.
18.7 crore funding from World Bank. That is the irony of all these projects. When that funding is start, center becomes just orphan. So for that, again funding is required, and that's how we have got a center of excellence from DST, and we want to contribute with it. Thank you very much, and I request you all to find time to visit. We request Dr. Bim and President Nepali Society of Agriculture Engineer. He will take not more than 5 minutes only. Dr. Bim Sesha from Nepali Society of Agriculture Engineers.
Thank you, Professor Dr. Indramani ji. And it's a really great privilege for me to have present this beautiful city of Parvani, and especially beautiful campus here. I represent Nepalese Society of Agriculture Engineer. It's okay. Okay, I represent Nepalese Society of Agriculture Engineers. I am a president because any member of the Nepalese Society of Agriculture Engineers could be a president, but currently I happen to be in a driving seat, so I steer the Agriculture Engineering Society in Nepal. We have around 500 plus agriculture engineers. Nepal, if you see, we are in the nestle of a Himalaya. Okay, and just for my introduction, as you can see there, I am currently teaching at Kathmandu University. The Kathmandu is the capital of Nepal, and I teach at Kathmandu University. And besides that, I am also, as Professor Indramani said, in Bangkok. I just now directly come from Thailand because I teach in the AIT, Asian Institute of Technology, and King Mongkut Institute of Technology. They have a collaboration made, and I teach at King Mongkut Institute of Technology in Landrabag in Bangkok. So that way it gives me a privilege to have students from Asia. And having worked with the Asian Association of Agriculture Engineers, where Professor Indramani is currently as a chairperson, a president of Asian Association of Agriculture Engineers. So we are trying to create some sort of synergy, some sort of commonalities, some sort of working team up within the aspiring agriculture engineers in Asia. So that is where we try to work on. And today I'm really privileged to speak few things about some of the works that our engineers have been working on, especially in because the topic, today's topic is about how the migrations from the rural community is happening towards the urban area and how to retain them. Some of this is a really a burning topic issues, how we can retain. Or, of course, one is a retention. I have 5 minutes, right? I will not speak a lot. So retention is one problem. Another, sustenance of agriculture is another problem. So can we go to another slide, please? Okay. So my topic today is Introduction to Agriculture Mechanization in Developing Countries with Case Studies in Nepal and Way Forward. So as you can see, agriculture is one of the most crucial aspects of economic growth, accounting about 4% of global domestic product. And some of the least developing countries, this goes more than 25%. So that means agriculture is one of the mainstay of the country. No matter how much industrialization happens, the agriculture still remains one of the important aspects. If you see in Nepal, Nepal is, as I said, there could be 3 regions, mountains, hills, and Terai. And most of the urban areas are getting agriculture land is being converted into, say, urban settlements. That is one of the problem. And other hand, in the rural communities, people are migrating to the cities, and cities people are again migrating to the big cities. So that problem is being, so maybe you can move on and on and on. So, yeah. So this is a kind of a scenarios in Nepal. You can see hill, mountain, and Terai regions are there. And you can see in the hill areas, it's the middle part of the city where Kathmandu and big cities are located. The productivity is relatively in between, whereas in Terai, there's a productivity is high and high level of people's migration. So it is a kind of a skewed human settlements is happening, meaning is that, you know, people are more very dense in some cities and people are not at all there in a mountain and high hill areas. So how to settle? These are some of the problems. These are the different major crops that is being used. Go ahead, please go. Yeah. This is a crop-wise yield comparisons and all. This is one of my students is doing on. And please go ahead. Yeah. And farm power, if you see the power in Nepal, mostly the people are using the subsistence agriculture systems. Mostly the power is either animal driven, and there's, having said we have agrarian or subsistence farming system, is that there's a strong scope of people to have used the mechanizations of bringing the technologies, that's the farm mechanizations in a country. Go ahead, please. Yeah. And farm power is, the availability of farm power machinery is not being justified as per the crop productions and productivity. So how we can have a balance between the productions, cost, and financial aspects so that people can have some sort of farm mechanization. One of the, I just heard in between, there's custom hiring kind of scenario that is being practiced in India, that we can very well do in Nepal as well, where farmers who are tempted to do the mechanizations that is not being economically being justified can have this farm mechanization through custom hiring. Please go ahead. Yeah, this is a farm power scenario in Nepal. I will leave it. Just go ahead. Yeah, this is a farm power in different regions of Nepal. Yeah, please go ahead. And this is a farm populations. If you see the populations in a farm, you can see that it is decreasing. The farm populations is decreasing, meaning is that a lot of peoples are shifting from agriculture practice to another areas, another promising ways of their livelihoods, and making the farmland barren, not being able to be grown. So how to make youth attracted towards agriculture, as I saw the few minutes before the slides, by making use of some drone or some kind of technologies. If those technologies can be brought into practice, maybe the youth can have some sort of attraction to remain in their agriculture. Please go ahead next, please. Yeah, this is how the palm populations is being driven.
Dr. Bhim, another 2-3 minutes.
Yes, please go ahead. Yeah. Okay. Okay, way forward. This is a slide where I wanted to stop. This is a way forward. One of the areas, Nepal, as you can see, it's a high mountain areas with the majority of Mount Everest and all. So the climate change is impacting a lot in high altitude areas. So how we can have agriculture practice in a sustainable way so that it will not disturb the climate change. The climate change, adverse effect of climate change could be. Recently there is a big conference, because in Thailand I was there in the Asia Hub meeting, and we're trying to develop some climate resilience technologies so that people can have practiced agriculture without disturbing the planet in the long term. So the climate smart agriculture can be one of the areas where we need to focus on. Innovative water management and farm mechanization systems is one of other areas where precious amount of water can be measured and can be used through some sort of a digital technologies for irrigation water management. Post-harvest of agro-processing with less GHG. So when I say GHG, it's a greenhouse gas emissions that can be reduced by making the agriculture processing techniques. Third one is soil and water conservation using bioengineering. In the first slides I was showing, I also teach at the University of Washington in Seattle, where I teach bioengineering. In the United States, we call not only agriculture engineers, because our colleagues here in India, I just wanted to say, you are Indian Society of Agriculture Engineer, and in America they say it is American Society of Agriculture and Biological Engineers. So I teach at the bioengineering department at University of Washington in Seattle. Having said bioengineering, a lot of agriculture engineers need to interface between the biological nature of soil, plant, or any living things with the technology, with the engineering, with any kind of mechanizations that could come into picture. So this biological interfacing can be done by ag engineers. So I have been teaching some of the bioengineering students at University of Washington in Seattle. That's why that comes to a picture where agriculture engineers from now on has to deal with the not only with the technology, but technology for the living things, that is a biological material. And I feel like a soil and water conservations could be done by using a modern and innovative bioengineering techniques. Next, I think, yeah. Thank you. That's a way I just wanted to tell you about some of the few things that our students are working, since the time is very limited. The most important thing is that I could speak, I can make my voice heard in this important gathering of ISAE and keep the continuation of the trend that we started from the Pune. And in Pune we were there, a few numbers of people, at this time in this place where Parvani is, it's just a great fortune for me to have interaction. I'll be more than happy to have more interaction.
Thank you, Dr. Bhim Shrestha. Thank you very much. I just want to remind that we signed the MOU between ISAE and NSAE in 2020, and it is 4 years now. So on all these aspects which we have mentioned, the best practices and best accomplishment of India, we can share with the Nepalese Society of Agriculture Engineers. So that MOU should be basically implemented.
Exactly. This is one of the, because to be very frank, agriculture is
Dr. Jha will present a memento to Dr. Bhim Shrestha. So you please.
So I just, on all 4 points which you mentioned in your conclusion slide, there is need. The MOU is just to not share the MOU, but let us share the work and achievement. With 2 parties. So thank you very much. Thank you, thank you.
And just a few things, I fully believe on the leadership of Dr. Professor Indramani Ji. So we have recently signed an MOU between Asian Association of Agriculture Engineers. When we say Asia, it starts from all the way from Japan to the Saudi, Israel, Palestine, all those areas, comes together. Because Asia, when we say it's really big. So he is currently leading the entire system. Because I studied in Japan, I was in Kyushu. So the Japanese societies of agriculture missionaries and JSAM we call, and we will try to organize even next year. We are planning to have a AAA.
Yeah, friends, this is an announcement that next year Asian Association of Agriculture and Engineering this international conference will be organized in Kathmandu. This year it was organized in Bangkok. So this time his team will organize in all agriculture and ISA and AAA have signed the MOU. So all are requested to come to Nepal. Thank you. You can invite.
And just telling you, I come from the Himalayan country, Nepal. This is one of the, I can say, very attractive place for the people from India to visit. And we'll be more than happy to welcome you in Kathmandu. And we'll decide take and team this afternoon so that entire agriculture engineer from Asia can assemble in Kathmandu. So next year, in year 2025, this year we organize this in Bangkok, and next year we are planning to have this Asian Association of Agriculture Engineer annual convention to be organized in Kathmandu. So I really would like to welcome you, to see you, visit you. That's why personally I'm here to come here to Bharwani to welcome you and to invite you to give this invitation so that we can have very meaningful interaction in Kathmandu in year 2025. Thank you very much.
So two presidents are meeting, my dear friends. President Indian Society of Agriculture Engineers and President Nepalese Society of Agriculture Engineers. Great meeting.
Thank you, Dr. Indramani, to have this conversation and presentation and bringing few people from outside country to make it really international. But there is a requirement of international participants. I do not know whether that number is crossed or not. But a little bit I will talk on the digital agriculture and automation and other things, which I face day-to-day basis. Friends, I tell you that most of the presentation from, I think Rahul also, a lot of appreciation you get and all get gifts. And also a lot of people are doing in engineering, agriculture, in digital agriculture. But really we are doing it learn from all the large system, NAR, National Agriculture Research and Education and Extension Systems, that these all technology related to agriculture we are not developing. We are not developing anything original. We are bringing from somewhere and using that. So others can also do it. Others are doing it. They are not telling that this is an engineering discipline. This is not only for engineers. You are also taking some software from other country using, so the extension people, so the agronomists, so the computer application. What is new in this? What is your addiction? And it is very hard to prove that we can do better than what others are doing in agriculture field. And how to do that? How to do that? It is I just put the question on all the students. And our faculties, I will tell you, our faculties, dean, directors are so reluctant to change themselves. जो भी बीटेक एमटेक पीएचडी में पढ़ाई होता है छोड़ दो उसको भूल जाओ read extra things what are the things coming in the field you are not reading not equipping not developing yourself some equipment some machinery which are really digital and made in India make in India is not developed in India then only your stake on the discipline will be there. Otherwise, there are so many so-called startups, companies are coming and they are giving whatever they are giving. People are accepting that, but when you are giving, then people people will ask you that it is your development. क्योंकि आप इंजीनियर हो, आपसे पूछा क्या ये आपका बनाया हुआ है, दूसरा कंपनी कहीं से कुछ भी लेके आएगा, सब आंख मूंद के एक्सेप्ट करेगा, भले ही वो गलत डाटा देता है. 50-60% information given by the startups in digital agriculture is wrong, and I have given a record to the national channel, that is the Doordarshan. जो जितने भी डेटा आते हैं उसमें 50-60% रॉन्ग इन्फॉर्मेशन होते हैं, क्योंकि उनके पास एक्चुअल एग्रीकल्चर का एक्सपीरियंस नहीं होता. वो कुछ यहाँ से लेता है, वहाँ से लेता है, ऐप डेवलप करता है, डिजिटल है, बटन दबाएगा कुछ ना कुछ डाटा आएगा ही, और लोग उसको एक्सेप्ट कर लेता है, वो अच्छा है. बट व्हेन द एग्रीकल्चर इंजीनियर्स से, देन पीपल आस्क दैट हाउ एक्यूरेट इट इज, whether it has been developed by you people or not. So राहुरी हो या कोई और संस्था हो, अपना डेवलपमेंट कुछ नहीं है. अभी the most recent challenge given to us, we have accepted a challenge. जो भी ड्रोन लैब है, आपने ड्रोन ले आया, कहीं से कुछ कर लिया, बना लिया, उड़ा लिया. हम बचपन में बांस का ड्रोन बनाते थे, उड़ाते थे. वही चीज है, हमने बनाया ड्रोन, कोई नहीं बनाया. एक भी कंपोनेंट हमारा है नहीं है. अभी ऑनरेबल प्राइम मिनिस्टर एग्रीकल्चर मिनिस्टर है, गिव ए चैलेंज. एक भी ड्रोन 10 से 15 मिनट ज्यादा उड़ नहीं सकता. फार्मर थक जाता है, कितने बार उसमें उड़ाऊं, कितने बार डालूं. But no agriculture engineers or no engineers, even other engineers are trying to improve the flight time. आधा घंटा कर दो, 1 घंटा कर दो. We have given this task to few young scientists, but not coming with a good concept. जब इसका 15 मिनट में जो फिर नीचे आ जाता है 10 मिनट में, इसको कम से कम 30 मिनट कैसे किया जाए, 1 घंटा कैसे किया जाए. एक बार भर दिया तो घूमता रहे सारा काम करके. बट दीज काइंड ऑफ बेसिक रिसर्च कोई नहीं करना चाहता. मेरे बच्चे सब सामने बैठे, कल भी मैंने कुछ बात किया था. यू ऑल हैव टू इक्विप योरसेल्फ. कोई टीचर नहीं पढ़ाएगा, किसी को नहीं आता, क्योंकि पढ़ के पढ़ाना नहीं चाहता. कोई जो पढ़ने का है वही पढ़ाना चाहता. So you have to read yourself. Few scientists in our institutions are reading extra things, and group of scientists, some institute in CIA and CPET, we are a very good team. They are reading themselves, taking training also, and have developed very good team to develop new machines where all circuit design, all electronics, everything is ours. And are getting successful slowly. But that few scientists will be very difficult to fulfill the requirement. ड्रोन हमारा नहीं है. ड्रोन को हम अपना बनाना चाहेंगे तो हमें उस पर रिसर्च करने की जरूरत है. उसके लिए आपको पढ़ने की जरूरत है, टीचर को पढ़ने की जरूरत है, साइंटिस्ट को पढ़ने की जरूरत है. जो नहीं हो रहा है और हम प्रूव करने में बहुत मुश्किल हमें हो रही है. दिस इज इंजीनियरिंग डिसिप्लिन, बिकॉज एवरीवन इज बाइंग एंड यूजिंग इट. So this is a matter of concern to ponders, all teachers, professors, vice chancellors, all. भाषण देना बड़ा आसान है, मेरा तो ऐसे कब भाषण होता है. अच्छा स्लाइड दिखाना आसान है, लेकिन ग्राउंड पर कितने लोग काम करते हैं, लैब में कितने लोग बिताते हैं, कोई नहीं बिताता. Except few younger. I appreciate few younger scientists are doing, whether by pressure, by interest, but they are doing. But that number should reach, number should increase at faster rate. यदि कम से कम 200-300 एग्रीकल्चर इंजीनियर नहीं करेगा ये काम, तो आपका डिसिप्लिन आपके हाथ से चला. With these words, I thank Dr. Indramani to conduct this session, and this is the last session of Indian Society of Agricultural Engineers of this group. This group means that council. Thank you all from the council side, I say council side, and also we have the valedictory session. We will discuss some more things. I have observed, I have gone to all the sessions. Also farmer session, student session. There I will take some more time to share what I have observed, so that the further how we can further improve. Thank you, Dr. Indranji.
Thank you, Raja. Wonderful friends, the call from Dr. Jha is that work hard and come up with your own indigenous technology. We have to really work hard and about new technology. Yesterday in automation and mechanics and automation also I said that you have to come up with the technologies which work on the field for long hours, just not for demonstration and display. So very good message from Dr. Jha. But my dear friends, be always positive and work hard and time is yours. Now what else? We want to conclude the session, madam, tell me.
At the end of the last technical session of gifted ISA annual convention. That session is engineering innovation for next gen digital agriculture. I am very much thankful to Honorable Dr. S.N. Jha Sir, Deputy Director General Agriculture Engineering, ICAR New Delhi, for his valuable remarks and overall summary of this session. I am very much thankful to our Honorable Vice Chancellor Sir, Dr. Indramani Sir, for gracing this session as a chairperson and also for his valuable remarks during this session. Again, I am very much thankful to respected Dr. Dharmendra Saraswat Sir, Professor, Purdue University, USA, for gracing this function online as a chairperson and for delivering the lecture on innovative student-centric methods to prepare the next gen for engineering innovation. I am also thankful to respected Dr. S.D. Gorintiwal Sir, former Director of Research, MPKD Rahuri, for his lecture on revolutionary agriculture digital innovation for sustainable futures. I am also thankful respected Dr. Bhim Prasad Shestra, President, Nepali Society of Agriculture Engineer and Professor, Department of Mechanical Engineering, Kathmandu University, Nepal, for his introduction of the lecture on the introduction of agricultural mechanization in development capacity with conditions with case study in the Nepal and way forward. On behalf of Vasantram Naik Marathwada Krishi Vidyapith, I am thankful to all the eminent scientists, faculty, respected faculty present in this house. Lastly, I am thankful to everyone present in this house. Thank you sir. Thank you.
So with this, we close this session and request you all to move to convocation hall where we have valedictory session. Thank you. Dr.
Gore साहब बहुत बहुत स्वागत है आपका.
Thank you.